The next thing we're going to talk about is relative atomic mass. So masses of atoms in grams are very, very small, like nonsensically small. So for example, an atom of oxygen 16 has a mass of 2.656 times 10 to the minus 23 kilograms. What? That's awful. 10 to the minus 23? That doesn't mean anything. So in our minds, it's more convenient to use a relative scale. So we have to define a standard, and then we can make everything relative to that standard. Okay? So the standard that we're going to use is the nuclide carbon-12. And scientists selected that for a variety of reasons, which aren't really that important. Just remember that the nuclide carbon-12 is the standard. Okay? So it is assigned a mass of exactly 12 unified atomic mass units. It's a terrible unit. Okay? Unified atomic mass units. Its symbol is U. Much easier. Okay? 1 U is 1/12 the mass of a carbon-12 atom. Okay? Now, you'll notice that carbon-12 has 6 protons and 6 neutrons. Okay? And it might be tempting to say that 1 U is the mass of 1 proton and 1 neutron. But if you remember back, 1 proton and 1 neutron aren't actually the same mass. Okay? So everything else is based on this. But we'll get some weird things like magnesium-24. It doesn't have a unified atomic mass of 24. Its unified atomic mass is 23.985042. U. Okay? All right. Whew. So keep in mind that when we look at a periodic table, we're given 1 mass, okay? Now, we know that each atom, each element, is actually made up of a mixture of isotopes, okay? So, the percentage at which each nuclide of an element exists in nature is taken into account when calculating the average atomic mass of an element. Okay? So average atomic mass is just the weighted average of the masses of the isotopes. Okay? So I'm going to take this out of science, all right? Because there are lots of examples where we use weighted averages in everyday life. So for example, your grade in this class is a weighted average. Okay? Think about a box of marbles. Okay? This is a very concrete example that you can keep in mind, and you should know how to figure this out because you've done stuff like this in you did stuff like this in 7th grade, 8th grade. Okay? Let's say that you have a box of marbles, and the box of marbles is actually made up of marbles of 2 different masses. Okay? Some of the marbles have a mass of 2 grams, and some of the marbles have a mass of 3 grams. Okay? Well, how do you figure something like this out? Okay? I want you to pause, and I want you to see if you can get the correct answer. Okay? And then you can come back, and I'll kind of walk you through how to calculate this, and especially how I want you to calculate this. Okay? So, keep in mind that you can't just do 2.00 grams plus 3.00 grams over 2. You can't just take an average. That doesn't work, okay? Because you have to take into account that 25% of your marbles are 2 grams and 75% of your marbles are 3 grams, okay? So the way that I like to do this, okay, is I like to take each of you could kind of think about this by taking the percentages out and just saying, let's say that I have 100 marbles. How would I do this? Okay, well, you would take your 2 grams times the 25 marbles plus 3 grams times, let me get my correct number of significant figures here. 3 grams, 3.00 grams, times the 75 marbles. And then in order to make this correct, all you'd have to do is divide by the total number of marbles, right? Because this would give you the total mass, and then you'd be able to divide that by the total number of marbles. Well, you can do the same thing with percents, okay? You can just put in, you multiply 2.00 grams times 25% plus 3 grams times 75%, and then just divide that by 100%, okay? And that'll take care of the units, all right? Now keep in mind that when you multiply this together, the unit that you're, and remember order of operations, you have to multiply first and then add. So the unit for the product of these two things is going to be grams times percent, and the unit of this is going to be grams times percent. So then when you divide by 100%, the units go away. How great is that, right? Or the percentages go away and you're left with grams. Okay, so when I do this, I get 2.75 grams. Okay, and that's not being rigorous because these 25% and 75% technically have 2 sig figs. I just want to use this as like a simple example. All right, something that you would have done in the past. Okay, so now I'm going to take this and I'm going to move it into chemistry. Okay, so here's the problem. Naturally occurring copper consists of 69.15% copper 63, which has an atomic mass of this huge thing, and 30.85% copper 65, which has an atomic mass of all that stuff. What is the average atomic mass of copper? Okay, well, this is just calculating a weighted average. Okay, so I take the 69.15%, and I multiply that times 62.929601, okay? And that's U, plus 30.85% times 64.927794 U. And then all I have to do is take all of this and divide by 100%. Now, a lot of you, when you learned percentages, you would have learned to take this as 69.15% divided by 100%, and you get times 62.929601 U plus 30.85% divided by 100% times 64.927794 U. Okay? Either one of these methods will work. So this is one of those times where I'm going to say you do what is comfortable for you. Okay? I happen to like this top method because it makes sense based on the example that we did before. Oh, that's too far before. With the marbles, right? Because this is how I would calculate this with marbles. So I like to be able to relate it back to things that I've done in the past. Okay, so when I plug this into my calculator, I get my answer to 4 significant figures as 63.5 5, it's really 546, but it's 4 sig figs, right, because of the percentages. 63.55, and then I know that my unit for this top product will be percent U, and this one will be percent U. So when I add them together, the top is just going to have the unit of percent U and divide by percent, so it's just going to be U. So my I want an average atomic mass, so I know that the mass is going to be, the average atomic mass is going to be U. It's going to be a relative atomic mass, okay? And I know, I'm going to double check here, okay? One of the things that I see people do here is forget to check their work. I know that the average atomic mass has to be somewhere between 62.9 and 64.9. Okay, so you just have to kind of keep things in mind, right? If I had gotten an average atomic mass of, let's say, 6,355 U, I'll see people just leave that because they don't double check their work. All right. Now, one of the things that I want to do is I want to look at copper. And the average atomic mass of copper is 63.546. And you can ignore the stuff in parentheses, okay? There's an explanation down here that I don't want to go into right now, okay? Which rounds to 63.55. So these numbers at the bottom of the periodic table are the average atomic mass, or the mean relative mass, but it's the average atomic mass, okay? So these numbers have the unit U. Now, this is going to get confusing in a little while when I do some other stuff, but for now, I want you to remember that these numbers are average atomic mass with the symbol U.